Yes, in this video, we're going to put our newfound skill of making Taylor series to work. So we're going to make the fourth degree Taylor polynomial approximation for f of x equals e to the x about x equals 0, otherwise known as a Maclaurin polynomial since we're centered about x equals 0. Let's do this. So if you remember, what I like to do is I like to expand out our Taylor series. In general, our nth term is f to the nth derivative, evaluated at whatever our center value is, in this case that's 0, over that same derivative power, or the same derivative order, is going to be the same factorial number times x minus c to the nth. That same power right there. Okay, let's expand it out. So in this case, I'm going to have f of 0 plus f prime of 0 times x, and that's over 1 factorial, plus, and we're going to go out to the fourth degree, right? Fourth order, some teachers call it. F double prime of 0 all over 2 factorial, x squared, plus f triple prime of 0 all over 3 factorial times x cubed, plus f to the fourth derivative at 0 all over 4 factorial times x to the fourth. And if you're looking at that like, where is he getting this from? Check out video 1 in this lesson so you understand what the heck I'm talking about with getting this out. And then practice expanding it out every time. I think it's very important we expand it out like this and then enter in our information. Then you'll get so good at these Taylor expansions. Okay, so we need our bank, right? So what's the bank going to be? Well, first that's going to be values of nth order of the derivative of x, and then values of that nth order derivative at c. In this case, that's going to be at 0, wherever we're centered. So this could be really easy to generate. F of x, you'll see why in a second, is e to the x. What's the derivative of e to the x? The derivative of e to the x is e to the x. And then the second derivative of e to the x, well, this is going to be easy to calculate, is e to the x. And the third derivative of e to the x is e to the x. And you guessed it, the fourth derivative, which is where we stop because that's what we want to go to. Fourth degree, fourth derivative of x is e to the x. So plugging in 0 is not going to change anything. F of 0 is equal to 1. E to the 0 is 1. F prime of 0 is going to be equal to 1. F double prime of 0 also equal to 1. F triple prime of 0 is equal to 1. And F quadruple prime is equal to 1. I think that's 1 in German. I don't know German very well. Okay, anyway, so that'd be 1 in French. So that would be equal to 1. So now we've got all 1s. Just plug it into your Taylor expansion here and you'll have your fourth degree Taylor polynomial. That's it. So 1 goes in for f of 0, bam, plus 1 over 1 factorial. I'm going to write this, by the way, as p sub 4 of x. That's the fourth degree polynomial for e to the x in this case. Plus, we're going to plug in 1 here. That's 1 over 1 factorial. We'll simplify later, x to the first, plus another 1 over 2 factorial times x squared, plus 1 for f triple prime over 3 factorial x cubed, plus 1 over 4 factorial x to the fourth. And we'll neaten this up a little bit. This is 1 plus x squared over 2 factorial. It's actually a really easy one to memorize, which I highly advise you do that, plus x cubed over 3 factorial plus x to the fourth over 4 factorial. That right there is an approximation for e to the x, a polynomial approximation for e to the x, and it's gorgeous. All right, let's keep rocking this. It says use your answer to approximate e to the 0.5 and compare this value to what your calculator approximates the value to be. This is just neat to see. So what we're going to do is we're going to do p sub 4 of 0.5. And essentially that means we take 0.5 and plug it in here. So that's going to be 1 plus 0.5 plus 0.5 squared all over 2 factorial, plus 0.5 cubed all over 3 factorial, plus 0.5 to the fourth all over 4 factorial. I'll be back with you in a moment with both what the calculator says e to the 0.5 is, as well as what our polynomial says. Let's check it out in a second. And through the power of video editing, not so great video editing, we have 1.648437 for our polynomial approximation out to the fourth order, or fourth degree. And the true value, I'm putting that in quotes because guess what your calculator is using to approximate e to the 0.5? It's using this polynomial, but expanded out to higher degrees. So it gets 1.6487. So we go out to the 10,000th place to see that we're off by actually basically around 2 10,000ths, 2 or 3 10,000ths. That's not bad. Pretty darn good approximation since we're only out to the 4th degree. Oh, it's beautiful. Okay, so I'm going to end this video with the idea that you need to know thy Taylor series or Maclaurin series. I like to say know your Mac dogs. What does that mean? You need to memorize the following 4 Taylor series centered about x equals 0 or approximated at x equals 0. Know your Mac dogs, your Maclaurin series, because we're going to use them to build. We're going to use them a lot in the future. So these are all considered power series. A power series is very simply a polynomial that goes on and on and on and on and on forever, right? And so that's what this fits into, and we're building it using Taylor polynomials or Maclaurin polynomials. So e to the x we already saw is 1 plus x squared over 2 factorial plus x to the 3rd all over 3 factorial plus, and it follows that pattern where we're going to start everything at n equals 0 here in this particular slide. You don't have to, but it makes it easiest, and that's what most books do too. That'd be x to the n over n factorial. Literally, you start at x to the 0 is 1 over 0 factorial is 1. X to the 1 over 1 factorial is x. X to the 2 over 2 factorial, and so on and so forth. Know that, and know that that's centered about x equals 0. Okay, sine of x we saw in video 1 is x minus x cubed over 3 factorial plus x to the 5th all over 5 factorial. I'll do one more term, minus x to the 7th all over 7 factorial plus dot, dot, dot. And it keeps on going. We're alternating signs here. Starting at n equals 0, we'd start with a positive 1. Then you're getting x to the 2n plus 1. That gives you an odd value all over 2n plus 1 factorial. And it keeps on going on and on. Cosine, well, a couple ways we could get cosine. If you really want to be fancy, you could take the derivative of this polynomial because it's the derivative of sine. More on that down the road. Very cool. You could generate it using your Taylor polynomial expansion. For right now, I'm just going to say, hey, you need to know this, and I'm going to give it to you. It's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. It's all even powers. Minus x to the 6th all over 6 factorial plus dot, dot, dot. And it's still going to alternate the same way that sine did. It's going to be x not to the 2n plus 1, but to the 2n. You go up 0, 2, 4, 6. And then that's all over the same exact number in the denominator, right? This matched with that over 2n factorial, and we'll say that it keeps going on and on forever. That's your cosine. Now ln again, that one's not centered about x equals 0. Just as a little highlight here, it is centered about x equal to 1. This is an interesting one. It is going to be 1 and then minus x minus 1 and then plus. It's going to be x, well, plus 1/2 times x minus 1 squared. And that's kind of an interesting one, how it starts out there and matches up with all that. I'm going to make one correction. It doesn't start out with 1. My apologies. It starts out just x minus 1, like that. So it's x minus 1. And that's because if you plug in ln of 1 into this, you want that to equal 0. If we started out with 1, it wouldn't. Anyway, enough on that. This would then be a minus. We alternate signs here like this, plus 1/3 times x minus 1 cubed. This is one that you don't necessarily have to memorize for some teachers, but others want it memorized. I never did, but I'm not your teacher that gives you tests. The BC exam typically doesn't need you to memorize ln, but these three, oh yeah, know it for the exam. Plus dot, 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 plus. Well, what are we alternating here? Well, at n equals 0, we've got that first term, that x minus 1. So we know we're going to have that. We know in terms of these values, it appears that we've got 1 over, and if we just kind of do it all out, whatever that n power is to the n, but it's going to alternate, right? So we're not starting out, unfortunately, with negative 1 to the n, but n plus 1. That's because if I plug in n equals 1, right, if we start out with n equals 1 or n equals 0, we'd get over 0. That's a problem. So here we're starting at n equals 1. That's our start. If I plug that in, I get this is an even number, so that's positive. This is over 1, and x minus 1 to the 1. Boom. At 2, we would get an odd value. It's negative 1 over 2, x minus 1 squared, and so on and so forth. And it keeps on going on and on and on. Those are the power series. Know them. Start studying them now. I'll see you in the next video. Peace.